So Accelerate 7, this is going to be the second part of our lesson from May the 4th. We are diving into 24-2, so if you were gone with the orchestra, you're going to have to catch up on 2 lessons. So which of these shapes that we have here is what we had from before? Jackson?
We had A.
Yeah, we had shape A. We had a 2x4 reduction image. So this shape we know fits. That has a scale factor, we said, of 1/6. We had to multiply by 1/6 to get there. What other shapes match and what is their scale factor? Or what shape doesn't match? Olivia?
B matches and the scale factor is 1/12.
Yeah, B does match. It's a rotation of our shape, but it has a scale factor of 1/12. James?
D fits and the scale factor is 1/4, I think.
D fits and the scale factor is 1/4. Let's check it. 12 divided by 4 gives me 3. Boom, that works. 24 divided by 4 gives me 6.
He cut off part of the shape. Wait.
My length here should come out to here. So D does not work actually because the scale factor does not match when we go to do the length. Lily?
But C is the one that works.
But C is the one that uses the scale factor of 1/4. Does it make sense why, James? Yeah. So that's the easy trap to fall into. You recognize the 12 to the 3. It's a nice scale factor, 1/4. It looks like it's the same, but it's not quite. So D does not work there. A, B, and C all fit nicely together. So all of this talk about dilations is just to get us to recognizing similar figures. Similar figures are any 2 figures that share the exact same angle relationships. Your angles have to be congruent. That's one big misconception that people have. They think when we change the size, the angles change their size. I don't care if my rays are this long or if they're this long. That doesn't change the angle size. You can change the lengths of things and the angle size can stay the same. So we know that this cool little squiggly symbol means it is similar to, because before for congruence, we use the equal with the squiggly because that means it is similar and it is the same, which means it's congruent. If we only have the squiggly, then we only have similar. So we can get similar figures through any process that changes the size but does not change the angle dimensions. So we have some rotations and some flips and reflections going on. That all creates congruent shapes, but as soon as I change the scale of it, now I just have a similar figure. So even though it's changed its orientation, it's changed its quadrant, and it's changed its size, it is still similar. Questions? Cool. You guys are all like zombies today. This is why I don't drink the water. I don't trust it. I'm joking. You guys have nothing today. So if ABC is similar to NOP, we want to describe a sequence of rigid motions. And guys, this is where people get mixed up on the order that we work in. We have to go from ABC to NOP. So the first thing that I like to identify is it an enlargement or a reduction? From ABC to NOP, do I get bigger or smaller? Smaller. So we have a reduction. So that tells me that my scale factor will be less than 1. What sides would be good to compare to find my scale factor? Jackson?
B to C and O to P.
BC to OP, because they're both horizontal, the lengths are easy to compare. I have a length of 4 to a length of 2, so I set up my new over my old, and I get a scale factor of 1/2. But we have to figure out where are we dilating from, and then what other movement takes me to my new image. So if I scale factor, if I have a reduction by 1/2 I need to say from what point? Well, if I reduce it from point B, then it stays in the same location. And would just be there. Or if I do it with a center from point A, it would be there. Or if I do it with a center from point C, it would be there. So where do we want my dilation center to be?
Point C.
Yeah, I mean, any of them can work. So we'll say we're going to do a dilation from C. Ooh, crap. I have a stuck center. So if my center has to be 0, 0, where is this shape going to end up? Oh, don't do that.
Oh, darn.
How do I figure out where my shape ends up if my dilation center is fixed? It would have been easy if we could choose our dilation center, because then I could just translate up real quick and we'd be done. But I can't use center C. I have to use 0, 0. What was the rule that we had when I dilate from the center? What about those rays?
Oh, they can,
Yeah?
they can be as long as short as. Oh, no, never mind.
Should you?
It's angles. They can. Yeah.
If I draw a ray from here through A, here through B, here through C, what do I know about my dilated image? Go ahead.
It has to be somewhere on the ray.
My points have to be on that ray, and since my dilation factor is 1/2, my points will be half as far as they originally were from the origin. So a dilation center of the origin is actually not bad, because what I do in order to find those points is I take one of my values. Let's say we take point C, since we wanted to pick on that point. Point C is at 2, -4. Since I'm dilating from the center, I know that C prime, everything will just be half of what it was. So it's going to become 1, -2. That tells me where my C prime should be. And because I know where C prime is, I know where my dilated image is. So now I know my dilated image has to be right there, because C has to be on this point, 1, -2, and I already know the shape of my dilated image. So from there, what do we have to do after the dilation? So then we would say, then translate. What's our translation? Nate?
X moves 1
Yep.
to the right. Plus 1. And then Y is plus 2.
Absolutely correct, sir. Any questions on how we figured out where my dilated shape goes? Any questions on how we then determined the translation? Cool. So try the got it with a dilation center stuck at 0, 0, and that rectangle dilating from ABC to DEF. What sequence of motions gets me there? Think it through. Remember, we dilate first, then we translate. Actually, this one is asking, sorry, I said that incorrectly. This one is asking for a sequence of rigid motions, then followed by a dilation. So we're actually going to dilate last, which makes this even harder, because you have to get your pre-image into position to then dilate and become what you want it to be. So you kind of have to work backwards here. This is when I love the smart board. Where should we move? What point is a good indicator or a good working point? And I'll go ahead and even give the hint. What point in our image, our final figure, is a good point to work from? Especially if we think about working backwards. Shahib? Why F?
Because if you were to make a ray from C to F, it would connect.
Because my dilation center is stuck at 0, 0, I know that ray rule is going to apply from my origin. And to get to F, that's a straight line. So I know that wherever my C prime ends up will need to be on that line before it dilates. I know that my A prime will need to be on this line, but that's not quite as helpful. My B prime will end up on the x-axis, so actually my B prime would be a good one as well. Anyone figure out our scale factor? A nice, easy way to do that? Think of this like slope. When we determine the slope, how do we do that?
The change of X and Y.
Changes to X and Y. Look at, in your pre-image being ABC, what's my change? X, Y. Well, to go from B to A, I go over 1, up 2. Look at your image, compare that.
Oh.
Nate?
It's the scale factor is 1/2.
Close.
Oh. Yeah.
We're going from ABC to DEF.
Oh.
It's an enlargement. So my scale factor is 2. Because the shift from point to point doubled what it does, we know my scale factor has to be 2. Now that's exactly the same principle as using the distance formula. We just did a whole lot less work. And a whole lot less work makes our life easier. Math is all about efficiency. How can I do things easily and accurately? So my scale factor is 2. I know that I'm going to double the distance from the origin to get to my image, my final. So if I know that from the origin to my image point is a distance of 4, then I know that from my origin to my pre-dilation point would need to be 2. So I know that my pre-dilation point needs to be right here. So I need to get point C over to that point, which I know that landing point, I guess we could say, or an end point. I know that end point is 0, -2. So what I'm asking is, how do I get C, which is currently at 3, -1, how do I get it to that end point?
Left 3 and down 1.
So we can start our commands or whatever we want to say. So we could say translate. And I honestly think the easiest way to talk about translations is the change notation. So I'm going to say x. What happens to my x? Well, from 3 to 0. Translate x minus 3. From y goes from -1 to -2. So y has to go down by 1. Then dilate from 0, 0 with a scale factor of 2. So the first thing we do that Nate told us to do is we shift 3 over, 1 down, and we land right here. Notice all the points are on their rays that they should be. I have my point C prime on the ray, A prime on the ray, and B prime on the ray. Then if I double everything, it'll zoom, or however you want to think about it, and end up right where it belongs. Any questions, comments, concerns on this? So you have to look at what they're asking for. The big trick there was that we had to do our rigid motions before we did our dilation. If we could have done the dilation first, it would have been easier. We're all good on this. It makes sense? One of the biggest things I got docked for in college was wait time. I was always trying to move really, really fast. And you guys probably noticed that with me. I move quickly, but you have to stop and wait for questions. That's tough for me. Moving on. We're going to step on into part 2 for the bottom of the front page there. So we want to describe a sequence of rigid motions followed by a dilation with center 0, 0. So same thing, but again, we have to move first. So try this on your own. Going to give you a moment. Now I'll go ahead and point out the trick here, because I don't want you to do a bunch of work and then get mad at me. A has to map to E, B has to map to F, C to G, and D to H. So if I look at A mapping to E, and if I look at B mapping to F, notice that it's not just a slide. That's my big, I don't want you to be mad at me. I don't like it when you guys get mad at me. I want to see if one of you can tell me everything without making a mistake. Tell me every motion we have to make and then our dilation factor. One of the first things that's easy to identify here, and we like to start with what's easy. What's our scale factor? If we're going from A, B, C, D to E, F, G, H, hey, 1/3. We have a reduction happening here. We're getting smaller. So then, we know that has to happen last, though. Do we have any like easy points or indicator points that help me know where I'm trying to get to? Like, think about working backwards. If we know our dilation center is at 0, 0, then again, I know that those rays from my origin point would have to line up. That's not a good one. That's not a good one either. Close. So do we have any points that are nice and easy to work with?
Well, I have this, and then I have a way.
Okay.
So, I kind of think H and E is kind of good to work with.
Okay.
A and D. I think that's.
So comparing H and E with A and D. So we know A goes to E. D goes to H. Okay. So what do you think we got to do first?
I think we should reflect over the y-axis.
Now I want to challenge you. Is there a way to make our reflection the only thing we do before the dilation? Peyton thinks there is. What one? If we reflect over the line x equals 1, that's this line right here, every point will go as far away from it on the other side as it was originally. So A, which is 1 away, will end up right here as A prime. And notice it's now on the ray it's supposed to be on. D, which starts out 1, 2, 3, 4 away, will be 1, 2, 3, 4 away from that line of reflection, not from the axis, but from my line of reflection, which puts me out here on the ray it's supposed to be on. B is 1 away, so B prime ends up on the ray it's supposed to be on, and C prime is 4 away. It goes 4 away on the ray it's supposed to be on. Any confusion why shifting what we reflect over puts me in the perfect spot? Because if I had just reflected the axis, A is 2 away from the axis, it would end up 2 away from the axis here. I'd then have to bring it back. I'd have to translate. And I mean, I can, but this is even simpler. We reflect over that line and we are where we want to be. Aside from, we then have to dilate. So we would say then dilate from 0, 0 with a scale factor of 130. Questions, comments, concerns? All right, I will get both of these posted, and we may just do a workday tomorrow to prep for a test and get any of this done. Go ahead and tentatively think that's what we'll do. I may post homework beyond this one because I think you guys are probably up for the challenge. I don't think there's any way that we're going to finish this chapter, so stay tuned on what will actually be like the mastery requirement. It'll probably just be to have your practices done. We'll give you mastery for the chapter, so stay tuned for that. Have a wonderful day, guys.